We're on the internet all the time, every single day. But have you ever really stopped to think about the actual physical hardware that makes it all work? Well, let's pull back the curtain and dive into the invisible world of network devices.
So you see something you like, you click on it, and poof, a new page loads. But what really happens in that split second? We're going to follow that single click, that one little piece of data on its incredible journey from your screen, maybe across the world, and all the way back again. And it's all thanks to a whole team of specialized gadgets working together perfectly.
All right, so the journey starts right here, close to home, inside what's called your local area network, or LAN. This is basically your personal network bubble, where your computer, your phone, your game console, they're all chatting with each other.
Okay, let's go back in time a little bit. The first device on the scene was called a hub. And you can think of it like a town crier standing in the middle of a room. When it gets a message, it has no idea who it's for, so it just shouts it out to, well, everybody. Every single device gets the message, whether they need it or not. Pretty simple, but, not exactly efficient or private.
And yeah, this really shows you the difference. On one side, you've got the hub, just creating a ton of noise and unnecessary traffic. But on the other side, you have its much, much smarter successor, the switch. It takes a way more targeted approach.
So enter the switch. This thing is way more intelligent. Instead of a town crier, think of it like a super efficient mail sorter inside your office building. It actually reads the specific address on each piece of data and delivers it only to the device that's supposed to get it. This makes everything way faster, way more efficient, and a whole lot more secure.
So how does it pull this off? Well, technically, it works at what's called Layer 2, which is all about local connections. It uses something called a MAC address, which you can think of as a unique, permanent fingerprint for every single one of your devices. The switch builds a little table of all these fingerprints so it knows exactly where to send the data. This is so important because it cuts down on all that network chatter. It's why one person can be in a lag-free video game while someone else is streaming a 4K movie in the next room because their data isn't bumping into each other.
Okay, so that's all fine and dandy for things you plug in with a cable. But let's be real, most of us are on Wi-Fi these days, right? So what's the deal there? How does that work?
Well, that is the job of the access point, or AP for short. It's basically the bridge that connects the wireless world to that wired network we were just talking about. The Wi-Fi router in your house, that's got an access point built right in. But you see them everywhere, airports, coffee shops, hotels, creating those Wi-Fi hotspots we all depend on. So our little data packet has successfully navigated your local network. Now, it's ready for the big time. It's time to leave the building and travel out onto the huge global superhighway that is the internet.
And for this part of the trip, we have to meet the most important device of all, the router. If a switch is the mail sorter for one building, the router is like the main post office for the entire city. It looks at the final destination, the IP address. Now, if the MAC address was the device's permanent fingerprint, the IP address is like its temporary mailing address on the internet. And the router uses this IP address to make the super important decision. What's the best, fastest, most efficient path for this piece of data to take?
And here's the key thing to get. A router works at Layer 3, which is all about connecting different networks. It's the device that connects your little local network, your LAN, to the massive wide area network, or WAN, which for all of us is basically the internet. It's the gatekeeper. It's also your first line of defense, acting as a firewall to keep the bad stuff out. But wait, how does your router actually talk to your internet service provider? Well, they kind of speak different languages. It needs a translator. And that translator is the modem. See, your computer speaks in digital ones and zeros, but the lines running into your house, whether it's cable or fiber, often use analog signals. The modem's whole job is to translate back and forth between the two so that everyone can understand each other.
All right, before we put this whole journey together, let's take a quick look at a couple of specialist gadgets that solve some super common problems you've probably run into.
Oh, you know this feeling, right? You're trying to stream a show in the bedroom, but the Wi-Fi router is all the way in the living room, and the signal just can't quite make it. It's that classic dead zone problem.
Well, say hello to the repeater. It's a really simple but genius device. It just listens for that weak dying Wi-Fi signal, cleans it up, gives it a shot of energy, and then rebroadcasts it with full strength. It basically just extends the reach of your network further into your home.
Okay, here's another scenario for you. Imagine a company has offices in two buildings, right across the street from each other. How do you get their two separate local networks to act like they're one big unified network?
That is a job for a network bridge. It's a smart device that connects those two LANs. It's clever enough to filter the traffic so that data that's only meant for one office doesn't needlessly cross the bridge and clog up the network in the other building. It really helps improve the performance for everyone.
All right, so we've met the whole crew. We have all the individual players on the field. Now let's see how this team actually works together, with each device playing its own unique and absolutely critical role.
Man, this table really lays it all out, doesn't it? Let's just quickly walk through it. You can see each device we've talked about, the OSI layer it works on, its main purpose, and a classic real-world example. You can see the progression, right? From the really simple hub on the physical layer all the way up to the intelligent router working on the network layer. Every single piece has its place.
And you know what? If you only remember one thing from all of this, make it this little mantra right here. A hub just connects. A switch directs traffic inside one network, and a router decides the path between different networks. Connects, directs, decides. Simple. So let's trace that journey one last time, lightning round style. Step 1, you connect, either with a wire to a switch or wirelessly to an access point. Step 2, the switch smartly directs your click across your local network. Step 3, the router looks at the destination and decides the best path to send it out onto the internet. And Step 4, the modem translates the signal for your ISP to handle. It's this beautiful, high-speed relay race happening millions of times a second. It's kind of wild when you think about it, right? All of this happens in the blink of an eye, powered by these little boxes that most of us just hide behind a desk and forget about. They really are the unsung heroes of our entire digital world.
And the simple truth is this. Without this whole team of specialized hardware, there would be no internet. That's it. No streaming, no social media, no working from home, no video calls. Our entire modern world of communication would just stop.
So, that leaves us with one last, pretty cool question. Now that you know how it all works today, what about tomorrow? As we demand more and more speed and create more and more data, how are these devices going to have to evolve? What will the router of the future even be capable of? The journey of our data? Well, it's really just getting started.